Consider a relation R defined on the set A, which is the set of first 5 natural numbers, and the relation is defined as the ordered pair x comma y belongs to the relation if and only if x is less than or equals to y. Express R as a set of ordered pairs and additionally determine its domain and range. Okay, let us begin. So first, let's note down whatever we are being provided with. So here we have the set A. So here set A is the set of first 5 natural numbers. So let's write the set in the roster form. So we have the elements 1, 2, 3, 4 and 5. So these are the first 5 natural numbers. Right. Next, we have the relation R. Now the relation R is going to be the set of ordered pairs x comma y. Now what are x and y here? Such that x belongs to the set A and y belongs to the set A as well, because this is a relation on R with the condition that x is going to be less than or equals to y. So our goal will be to find out this relation R. So since R is a relation on the set A, that simply means we have the universal set, which is the Cartesian product of the set A with itself. And from this Cartesian product, we have to find out certain ordered pairs which follows the relation that x is less than or equals to y. Okay, let us begin. So here, let's say we consider x to be equals to 1. And we're picking up this 1 from the set A, and then we have to pick up some other elements of y from that same set A. That means y could take the value 1, 2, 3, 4 or 5 such that it meets the condition that x is less than or equals to y. So there is only one possibility, that means y equals to 1, because we know 1 is clearly less than or equals to 1. 1 is equals to 1, so this is a valid relation, which means that 1 R1, this is a relation, or that means 1 is related to 1. So next element that we will pick up, so let's keep x as simply equals to 1. Fine. Now we will be picking up y to be equals to 2. Now, is it not true that 1 is less than 2? Yes, that's definitely true. 1 is always less than 2, which means that we have a relation 1R2. Fine. Now that means we can pick up x to be equals to 1 and y to be equals to 3, making 1R3 true as well. Then we can have 1R4, 1 is less than 4, and we can have 1R5. Okay. Next, what we can pick? We can pick up 2. We can pick up x to be equals to 2. However, we cannot pick up y to be equals to 1, because then in that case we'll have 2 less than 1, which is not true. But we can pick up 2, y to be equals to 2, because clearly y, if we take y to be equals to 2, then 2 will become less than or equals to 2, or in other words, we can say 2 equals to 2. So we have a relation 2R2. We can pick up y to be equals to 3, keeping x fixed at 2. Then we have 2R4, and then we have 2R5. Okay. Next, we can pick up 3R3. Then we can pick up 3R4. Next, we have 3R5. If we pick x to be equals to 4, then we have 4R4, and we can have 4R5. And then finally, we have 5R5. So these are the possibilities. So we have 1, 2, 3, 4, 5. Total of 15 ordered pairs that are possible. So our goal will be to express R as a set of ordered pairs. So let's do that. So R is now going to be the set of ordered pairs, which is going to be a total of 15 ordered pairs. So 1R1 can be expressed in terms of the ordered pair as 1, 1. Next we have 1R2. Now that becomes 1, 2. Followed by we have 1, 3. Next we have 1, 4. We have 1, 5. Next we have 2, 2. We have 2, 3. We have 2, 4. Then we have 2, 5. We have 3, 3. Then we have 3, 4. Next we have 3, 5. And then we have 4, 4 and 4, 5. And finally one more ordered pair, which is going to be 5, 5. So this is the relation R expressed in terms of its ordered pair. Our next goal will be to determine the domain and range of the relation R. That's a very simple task. So we'll first begin by computing the domain of R relation R. What is the domain? The domain is simply defined as take the first element of each of the ordered pairs. Here we have 1, we have 2, we have 3, we have 4, and we have 5. So 1, 2, 3, 5. So these elements are going to be the domain of the relation R. Then we will find out the range of the relation R. Now to find out the range, all we have to do is pick up the second element of each of the ordered pairs. So here we have 1, 2, 3, 4, 5. Again, the 1, 2, 3, 4, 5, these are repeating, but we will not consider the repetition. So we have 1, 2, 3, 4, and 5. Now, this is going to be the range. Now, since we see here that the range also contains all the elements of the set A, so this is also going to be the codomain of the relation R as well. So here we have also observed that the domain and the range of the relation R are equal to each other.